Okay, so today a nice, quick, easy video for you. So we're going to be looking at the transition elements and the noble gases. So first of all, we'll look at the transition elements, and then we'll look at the noble gases, and then finally we'll look at a few exam style questions. So what do we have? We have the transition elements. So the transition elements are the classic metals. If you are imagining a metal in your head right now, you are probably imagining a transition element. These are your classic metals. So we've got iron, we've got copper, we've got silver, we've got gold. These are the metals you know and love. So because of that, they have the classic metal properties. So here are the properties that they have, and we'll just quickly talk through all of these. So so they have high density. So we can't say they're heavy. That's not very GCSE. We need to talk about it in terms of density. And they have a very high density. So if you pick them up, they feel heavy, and that's because they have high densities. Especially things like gold. If you pick up a chunk of gold, you're really going to feel it. They also have very high melting and boiling points, and this is because they have very strong metallic bonding. This makes them great for building materials, and most of the things that are built in this world contain steel, which is iron. Okay, on to a few slightly more, not obvious properties with these final three. So they form colored compounds. So this means when they're bonded with other things, usually non-metals, they have some lovely colors. So here, this is copper sulfate crystals. So copper sulfate crystals and a copper sulfate solution is this lovely blue color. Pretty much most of them, when they're bonded to a non-metal, they have these lovely colors. And because of this, they're used as paint pigments. They can be used as a catalyst. So the main example you need to know about is iron is used as a catalyst in the Haber process. So they're very good at acting as a catalyst because they're very good at kind of forming temporary bonds with things in the reaction. That's kind of how catalysts work. Not that you need to know that. And our final thing is the ions have a different oxidation state. So what does that mean? So an iron is anything with a charge, and a different oxidation state just means that they can form different charges. So comparing this to like the group 1 and group 2 metals, so everything in group 1 can only form a +1 charge because it can only lose 1 electron. Everything in group 2 forms a +2 charge because it loses 2 electrons. Well, if we compare this to the transition metals, they're happy, they're comfortable losing a range of electrons. So we can use iron as an example. Let's make that slightly more legible. So iron forms a 2+ charge, but iron can also have a 3+ charge. What else can we use as an example? Well, let's use copper. So copper can have a 2+ charge, but copper can also be +1. And we could go on and on. So they like to have variable oxidation states, and that's just a special property of the transition elements. So you don't need to worry too much about why. Learn about that in A level and IB. But for now, you just need to be happy that they can have these different charges. So how do you know how to write the formula for these metals? Because if they've got a different charge, that's going to give them a different formula. Well, it gets written down. So we could have iron 2 fluoride, and the 2 in Roman numerals tells you the charge on the metal. And then if we compare this to a different compound, iron 3 fluoride, so the 3 here, and then from this we can figure out what their formula is going to be. So they're going to have slightly different formulas. So iron 2 chloride would be FeCl2, and iron 3 chloride would be FeCl3. And again, it's just from the swapping over valency method. This is how we've got these formulas here. So there we go. It's pretty fun, isn't it? Okay, so now on to the noble gases, and here is what AI thinks they look like. So here we've got gases existing on their own, and this is pretty true, as we will see why in a second. So they do exist on their own. That just means they're monoatomic, And yeah, they exist on their own because they are unreactive. And these two properties are explained by their electronic configuration. So they have a full outer shell. So let's have a look at neon. So neon, yeah, has 10 positive protons, so it has 10 negative electrons. So we can see in this beautiful diagram here that, yeah, it has a full outer shell, and this is true for all of the noble gases. So yeah, because they have a full outer shell, they don't need to gain or lose electrons, so therefore they don't need to interact with any other element. So this is why they're monoatomic, and this is why they are so unreactive. In fact, they're so unreactive that they weren't even discovered until relatively recently, because yeah, they're gases, they don't bond with anything, nobody could find them. So there we go, so that's the noble gases. Now on to some exam style questions. So what do we have? Let's just do a couple of multiple choices, one for transition metals, one for the noble gases, and I will leave the rest for you. And yeah, if you want to know the answers, then leave a comment in the description, video description, and I will get back to you. And if you want even more chemistry help, then please do check out my website. The link is in the description, and yeah, you can find out about chemistry tutoring, you know, which is really a lot of fun. So what do we have here? We have our question. So which of the following is a characteristic property of a transition element? So let's go through them one by one. Form only one type of ion? I don't think so. They have low melting and boiling points? I don't think so. Variable oxidation states? Probably. And poor conductors of electricity? Not true. They are in fact very good conductors of electricity. So our correct answer must be C. I'll leave question 2 for you. Let's have a look at this multiple choice. So this is one of the noble gases. So which of the following is a correct property of a noble gas of the noble gases? Highly reactive? No way. Exist as diatomic molecules? They do not. But an example of something that does is, yeah, the halogens, but they're not halogen. Have a full outer shell? Yes, please. And they form compounds with metals? No way. They don't form compounds with anything. So again, our answer is C. Okay, so there we go. Thank you for watching, and remember to finish the rest of those questions. That is great revision. And yeah, if you like the video, please do like and subscribe and tell all of your chemistry friends. Okay, I will catch you in the next one. Bye.